This is number 62, part C in chapter 18. It asks us to solve for the cell potential of the given redox reaction. And so here we have lead oxide and tin, and under acidic conditions is going to react in a redox nature to make lead plus 2 as well as tin plus 2, and then we have some water as a result of balancing there too. And so we want to determine the cell potential. And so what we need to do is recognize what is being reduced, what is being oxidized, because our cell potential is going to equal that reduction potential minus our potential for oxidation. And we're just going to get those values from the table, but we have to know the half reactions for this whole process in order to get there. And so the easiest one to recognize is the tin. The tin is monoatomic, and it's going from tin solid to tin plus 2, right? And so that's an oxidation process. The lead oxide, is also going to plus 2, but if we start to look at our numbers here, right, the lead here is actually in a plus 4 oxidation state, and it's a plus 2 oxidation state here, so we're actually adding 2 electrons for that process. And then the rest of it, the 2 H2Os and then the 4 H pluses, come from the balancing of that reaction. And so so that would be our reduction. So we have our oxidation, which is the tin, we have our reduction, which is the lead, and so we just want to look up those values in the table. And so if we look up our tin, we get a value for its oxidation to be negative 0.14 volts, and we're subtracting that from our reduction, which is 1.46 volts, and so we have that change in sign, and we get an answer of 1.6 volts for this cell. The question then goes on to ask us to determine if it's spontaneous as written, and since we get a positive cell potential, that means that this is spontaneous as written. That is number 62C in chapter 18.